Hey, this is a video for Regents Spiral number 3. Here we go. The sum of 2 times the square root of 54 and 2 square root of 6 is, sum is the operation of addition. So I'm going to set that up with addition. And remember, when you're adding or subtracting radicals, you need the same number under that radical symbol in order to be able to combine anything. So let's go ahead and put the square root of 54 into simplest radical form. So that way we can see if we can combine it with that 2 radical 6 afterwards. So if you'll recall, we put something into simplest radical form by typing the number under the radical over 6. Sorry, my dog is eating something weird. And then you're going to hit Control T. We're going to scroll through and look for the largest perfect square that is a factor of 54. So let's go ahead and look until we hit a perfect square. 6 and 9. Okay, perfect. So we're going to do the square root of 6 times the square root of 9. We're going to put the perfect square first. Now when we take the square root, we get 3 radical 6. So let's go ahead and keep the 2 out front. Now there's a 3 out front as well, and a radical 6 plus 2 radical 6. Oh, look, everything worked out perfectly. And it's going to work out perfectly. They're going to pick numbers like that. So I'm going to do 2 times 3 out front, which is 6, radical 6 plus 2 radical 6. I have 6 of these and 2 of these. I'm adding them together. All together, I have 8 radical 6s. So my answer is choice 4. 16. The functions f of x equals x squared minus 5x minus 14 and g of x equals x plus 2 are graphed on the same set of axes. What are the solutions to the equation f of x equals g of x? F of x equals g of x means you are looking for where the graphs cross. One is quadratic and one is linear. That means you're probably going to have 2 answers, okay? The easiest way to figure this out is to graph them both on the same set of axes. So let's do that in our graphing calculator. First, you're going to type in the quadratic, x squared minus 5x minus 14. Then you're going to type in the linear function the way you put 2 of the same graph on here. You hit tab. And then I have x plus 2. And then now let's find where they cross. So I'm going to do menu 5, 3. Tell it what to count by. Menu 5, 1. And I'm going to trace along the curve until I see where they cross. So that is telling me that that's a 0. And they're crossing at -2, 0. And then they're crossing again at 8, 10. Okay, so we're looking for the solutions, which means we're looking for the x's. So the x's will be -2 and 8. That's answer choice 3. Number 17. If x equals 4a squared minus a plus 3 and y equals a minus 5, then which polynomial is equivalent to the product of x and y? Equivalent means the same as or equal to. So if x is this guy and y is this guy, I need to find the product of x and y. Product is times, so I need to do x times y. Well, let's substitute in our x. And then we'll multiply it by our y. It looks like we're doing a trinomial times a binomial for multiplying. So let's go ahead and, and just to see where these came from, let's do this. Okay, you see where everything came from now. And in order to organize this multiplication here of a trinomial times a binomial, I'm going to set up a little box. So the trinomial goes up top. Doesn't matter how you set it up. And then I'm going to multiply across to fill in the box. So 4a squared times a gives me 4a cubed. Negative a times a gives me negative a squared. 3 times a gives me plus 3a. 4a squared times negative 5 gives me negative 20a squared. Negative a times negative 5 gives me 5 plus 5a. 3 times negative 5 gives me negative 15. I'm going to combine like terms, and I'm left with 4a cubed minus, I have 20 of these and one more of these, minus 21 of those. I have 3 of these and I add 5 more. That's going to give me 8 a's and then minus 15. So that's going to give us answer choice 4. That was a complicated problem. Okay, 18. What is an equation of the line that passes through 3, 7 and has a slope of 2? So, let me take a few minutes and try to find where this... Oh, no, they have it as a page on here, don't they? Yes. Turn to your reference sheet. I'm like, I'm going to have to open it up out of my file tree. No. Let's go to the page at the end. Where is it? Yes, here it is. And we're looking for the equation of a line where we have the slope and 1 point. So let's use linear equation, point, slope. So we're going to copy this onto our page. We always start with the formula and then fill it in. Let's start with the formula. We have a point, we have a slope. We're going to use point slope form of a line. That is y minus y1 is equal to m times x minus x1. This is x1, this is y1, and this is m, or the slope. So y1 is going to be y minus, there's a 7 standing in y1 spot. M is the slope of 2, and then x minus 3 is standing in x1 spot. So now let's go ahead and put, or match our answer choices. It is this one. 19. A geometric sequence with a common ratio of -3 is, so a common ratio of -3 in a geometric sequence tells me that r, or the multiplier, is going to be -3. So I'm looking for a multiplier of -3. And I'm going to examine these numbers and see how they change. And if times -3 is the way that they change, then he's my geometric sequence with a common ratio of -3. I can already tell right now that 10 times -3 is not -7. -2 times -3 could be, okay, let's figure that one out. -2 times -3, no, that would have to be a positive 6 here, and it's not positive, so we can eliminate that one. Let's do 14 times -3. 14 times -3 is not 11. No way, Jose. 4 times -3 is -12. Okay, -12 times -3 is positive 36. Yes, and then positive 36 times -3 is -108. The answer is choice 4. Okay, 20. When the equation 6 minus ax equals ax minus 2 is solved for x in terms of a, and a can't be 0, the result is, okay, so we're solving for x in terms of a. Means we're going to have x equals all by itself on the left-hand side. Solved for means that's the variable that's alone. So I've now got 6 minus ax, things weird, equals ax minus 2. So let's get all the ax's onto the left-hand side. So I have 6 minus, I already had -1, and then I took one more away. So I'll have minus 2ax, a little complicated. Minus 6, -2ax equals -8. I'm now going to divide both sides by -2 and an a, because that will get me x all by itself, okay? So now I have x equals -8 over -2. Let's see what that reduces to. That reduces to a 4. So the 4 is going to remain up here, and then this becomes a 1. So I now have 4 over a, which is choice 2. 21. Which function has zeros, -1, 3, and -4? So when we're given the zeros, we rewrite them like this, and then they become very easy to put into factored form. So when we take a 0 and put him into factored form, his sign flips. His sign would flip, and his sign would flip. So we're looking for an equation that has these 3 factors. This one has an x plus 3, so I can get rid of him. He has an x plus 3, so I can get rid of him. I now have x plus 1, x minus 3 in both, and then this one has the plus 4. So 21 is 3. The expression 5 to the a plus 2b is equivalent to. Okay, so when you see the word equivalent, it means you can use your calculator to test. So first I'm going to show you how to do this algebraically, then I'll show you how to check it on your calculator, okay? So 5 to the a plus 2b. Well, let's review our laws of exponents, right? When we multiply like bases, we add the exponents. So this guy would become 5 to the a plus b. What if you had more than one b though? What if you had 2 b's and you had something like this? He would combine to 5 to the a plus, how many b's are there now? 2 b's, okay? So we're just kind of looking for the version that's the same as this, right? When he's broken down. And that is going to be, well, this one's going to become 5 to the a plus 2 plus b, so that's not right. This one's going to become 5 to the a times, well, this has a different base than the 5, and I need the same base in order to use the laws of exponents. So I'm going to convert this 25 to a 5 squared, and then he's still being raised to the b power. A power to a power means you multiply. So I now have 5 to the a times 5 to the 2b, and this is in fact equivalent to 5 to the a plus 2b. So this guy's going to be my answer, choice 2. I'll show you how to check this on the calculator though if you didn't know where to start. So I see 2 variables in here, a and b. I'm going to store a value for a. I just usually pick like 2 and 3 in my calculator. So let's pick 3 and store it for b. So you do 3 control var b. So now 3 is b and 2 is a. Now I'm going to type in the original, right? 5 to the a plus 2b, and it'll give me a value. I now want to see which answer choice has the same value as that guy, right? So the value I'm trying to get to is 390625. And just in case I lose my calculator page, I stored a for 2 and b for 3. So now I'm going to type in the first answer choice and see if it's equivalent. 5 to the a times 5 to the 2 times 5 to the b. Okay, that is not the same as the original. Let's type in answer choice 2, which we think is the right choice. 5 to the a times 25 to the b. Yes, these match. So that's how you would check something like that. When it says equivalent, you can test if you're lost. 23. In an arithmetic sequence, the first term is 4. Okay, so this is giving me some good info. Arithmetic sequence, first term is 4. The third term, sorry, in IB they always use U's. I always forget to switch for them. In algebra, it's an A. Okay. The third term, a sub 3, is -2. What is the common difference? So we're trying to solve for D. Well, if we're given 2 terms and we're trying to find the common difference, I always make a table. This is the term number and this is the term. So the first term is 4, the second term is who knows, and the third term is -2. So I kind of do the slope here, right? So I'm going to do the change in the terms, right? To get from -2 to 4 over the change in the x's. Okay, so now I get negative 6 divided by 3 minus 1 is 2. That's negative 3, so the common difference is negative 3. You could also think about it as like, how do I get from here to here? I add a d. How do I get from here to here? I add a d. So 4 plus 2 d's gets me to negative 2. And then you could solve it that way. 2d equals negative 6. D equals negative 3. Or actually, there's another way you could do it if you want. So if you want to start with the equation, right? And you're like, okay, I know the first term is 4, the common difference is unknown, and then I have the third term as my clue, and he's negative 2. This is the third term, so n is 3. So now we get 2d plus 4 equals negative 2. Negative 6 equals negative 2. D is 3. Wait, why is it negative? That one should be positive. Wait, what's going on here? Oh, this changed to a negative and it shouldn't have. Okay. I was like, what's going on? Okay. Right. D is negative 3. There we go. 3 different ways to do the same thing. Who knows why that little negative spawned in? We'll never know. We'll never know. It's a mystery. Okay, let's go to 24. Joe is ordering water for his swimming pool. Can you order water? He determines the volume of his pool. Okay, so I got a pool, right? And I'm like, okay, the volume of his pool. We're thinking about this. We're envisioning water in a pool. Okay. And it's like a little cube worth of water. Okay. Okay. All right. This is the water in the pool. He determines the volume of his pool to be about 3,240 cubic feet. There are approximately 7.5 gallons of water in 1 cubic foot. A truckload holds 6,000 gallons of water. Which expression would allow Joe to correctly calculate the number of truckloads of water he needs to fill his pool? Okay, this is a dimensional analysis question, and we know that when we're doing dimensional analysis, we're looking for units to cancel. So units need to be in opposite portions of the fraction in order to cancel. So if we could just kind of cruise through and see where we have units not canceling, we can eliminate some answer choices. So like here we have gallons and gallons, both in the numerator, eliminate. Here we have feet cubed and feet cubed, both in the numerator, eliminate. And here we have feet cubed and feet cubed in the numerator, eliminate. The only one that works here is answer choice 4. Cool, we didn't even have to set it up. Okay, now we're just gonna kind of do the remaining problems. It looks like we have to do 29, so let's go down to 29. Okay. 29 says use the quadratic formula. Oh, if it says use the quadratic formula, you better be looking at your reference sheet and copying down the quadratic formula exactly the way you see it from your reference sheet. So scroll down, look at it, and you're like, oh, okay. Assuming you know where it is. Okay, here. And you look at the quadratic formula and you're like, okay, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Except I know that this is the discriminant. Okay. cool. I got all my stuff, and I got it from the reference sheet, which is always going to be there for you. So let's just make sure this guy's in standard form set equal to 0. He is. Now I can figure out what my A, my B, and my C are. A is 1, B is 3, C is -6. Now my discriminant is going to be found by doing B squared minus 4AC. Please, please, please put your B in parentheses. I don't know how many times I have to say it. So let's go ahead and type this in, right? I got 3 squared minus 4 times 1 times C. My discriminant is going to be 33. And exact means I'm going to have my answer in simplest radical form. X is equal to, B is -3. Well, B is 3, but there's a negative out front from the formula. The discriminant is 33, and then A is 1. So now I have X is equal to -3 plus or minus the square root of 33 all over 2. Let's just double check that there's no perfect squares that are factors of 33, but you could probably figure it out because the only factors of 33 are 1 and 33 and 11 and 3. But let's type it in anyway because, hey, maybe it's the day of the exam and you're nervous, right? So let's just double check. Control T, scroll through. I don't see any perfect squares in here at all, and they've just started repeating, so we're done. Okay, 30. Oh, factor completely. This question absolutely annihilated you guys in the mock exam. Oh my goodness. Factor completely means you need to pull out a GCF first. Okay, remember that? So I've got 5x cubed minus 80x. Factor means you are absolutely not setting this thing equal to anything. You are simply rewriting it in an equivalent form that now has parentheses, okay? So I'm going to see if I can identify a GCF. What do 5x cubed and 80x both share? They both have a GCF of x. Let's see if they have a GCF of a number. Does 80 go into, or does 5 go into 80 nicely? Let's see. 80 divided by 5. Oh, it does. Okay, so our GCF is now 5x. 5x will go outside of the parentheses. Inside of the parentheses, we will go through and divide to get our number inside. So 5's cancel. X cubed divided by x. What happens when we do x cubed divided by x? These cancel, we're left with x squared. Or laws of exponents, you can just know that if you're dividing like bases, you subtract the exponents, okay? Minus 80 divided by 5, we just did that on our calculator. It's 16, and x over x cancels. So now GCF means I not only pull out a GCF first, but I also need to look for additional factoring patterns at the end. Am I left with a trinomial that I can now factor? Am I left with the difference of two squares that I can now factor? I actually do have a difference of two squares right here. This is a perfect square and this is a perfect square, which means I can factor it the following way. The square root of x squared is x. In order to get a minus sign in the middle, you have to have opposite signs in the factors, and the square root of 16 is 4. This cannot be broken down any further. A good clue is that all the x's are to the first power. There's no way you could break this down any further. You're done. Okay, 33. 33. An object is launched upward at 64 feet per second from a platform 80 feet above the ground. The function f of s of t models the height of the object t seconds after launch. If s of t equals this graph right here, state the vertex of s of t and explain in detail what each coordinate means in the context of the problem. Okay, so it looks like we're going to have to graph this thing. Then we're going to use graph trace to find the vertex, which is the max or the min. We have to determine it based on the graph. And then we have to explain in the context of the problem what the vertex means. All right, let's do it. In my graph, I've got a downward facing parabola. That's going to tell me that this thing is going to have a maximum. Change your t's to x's when you type them into the calculator. And now let's graph trace. Menu 5-3. Menu 5-1. And we need to find the vertex. Oh, it just tells me right there. It's a maximum, and it is 2, 144. I then need to explain in detail what each coordinate means in the context of the problem. So this is a t, and this is an s of t. So when time, what is time being measured in? Seconds. When time equals 2 seconds, what are we launching here? Oh, just an object. The object is 144 feet, just feet above the ground. Okay, above the ground. I had to read it again to see. Okay. After the object is launched, how many seconds, so we're trying to solve for t, does it take for the object to hit the ground? Justify your answer. Okay, so the object hits the ground when t equals 5, because that is when s of t equals 0, aka the height of the object is 0. Okay? You could also justify it algebraically if you want. So if s of t is modeled by this function here, when I want to find where this guy is equal to 0, I would factor out a GCF. Let's see what these numbers end up being. 64 divided by negative 16 is going to give me negative 4t. And then 80 divided by negative 16 is going to be negative 5. This guy would factor to be and then I would split and solve. Reject that. This gives me a negative time. That doesn't make any sense. Reject that. And then time would have to be 5. Okay, so this is totally sufficient. If you're a math person and you prefer to show it algebraically, this is great as well. Okay. Question 34, here we go. Solve the system of equations algebraically for all values of x and y. Algebraically means you have to show the math. You can't just type it in. A correct answer with no work shown is only worth 1 point. But a very smart move is to graph this thing, find the solutions, and know what your answers are supposed to be once you're finished, right? So let's graph this thing, see what the answers are going to be, and then make sure that our math lines up. So I'm graphing these two. I'm going to see where they cross by tracing along. And it looks like they cross at -4, -1, and, sorry, I went too far, 2, 11. Why can't I just type this into linsolve? You can't, because these are not both linear. This would work if they were both linear, but this one's quadratic and this one's linear, so you can't just type it into linsolve. No linsolve. No, can't do it. Okay. So let's first make these equations cross by setting them equal. In math, when you make two equations cross, you set them equal. If this one equals y and this one equals y, you can set them both equal using the substitution method, right? So now I'm going to sort and get this guy in standard form set equal to 0. All right, and then let's see if we can factor this guy. Oh yeah, we can. I would have x plus 4, x minus 2. Okay. Set them both equal to 0. Okay, now don't forget, I feel like this is where most kids forget, right? You now have your x's, you got to find your y's. So I'm going to plug this back into the linear function because that's like the easiest way to find the y's, is to use the linear one. Now I'm going to plug in the x's and find out what the y's are supposed to be at each respective point of intersection. And then so then put it all together in two nice little points of intersection. This guy is going to be -4, -1, and this guy is going to be 2, 11. And then do those match the ones you found up top? They sure do. So those are your answers to this guy. Okay. All right, 35. 35 is your long one. He's worth 6 points. So make sure you get all 6 of those points by making nice graphs, right? You want to seal your graphs, straighten, extend, arrows, labels, okay? Jen joined the fan favorite movie club at the local movie theater. At this theater, the cost of admission in May and June remains the same. In May, she saw 2 matinees and 3 regular priced shows and spent $38.50. Okay, so 2 matinees, 3 regular priced shows, and she spent a total of $38.50. In June, she went to 6 matinees, 1 regular priced show, and spent a total of $47.50. Write a system of equations to represent the cost M of a matinee ticket and the cost R of a regular price ticket. System of equations means I'm writing 2 equations, and I'm going to let M equal cost of matinee ticket, and I'm going to let R equal cost of regular ticket. I just tried to abbreviate it by writing ticks, but it looks like you can't even read it. Okay, so remember, the last sentence in these problems always tells you what the variables should be, and it also tells you how many equations you have to write, okay? So let's go to the first thing. It says 2 matinees plus 3 regular, and your total was 30, it's not a 3, $38.50. Then you saw 6 matinees, and you got 1 regular price show, and you spent $47.50. All right, that's my 2 equations. Pretty easy, right? Then it said Jen said she spent $5.75 on each matinee, so M equals $5.75, and 9 on each regular. Is Jen correct? Justify your answer. So in order for these to be what each type of ticket costs, it has to work in both equations. And they love these questions because they want to see, are you just going to test it in one and then it's going to work in one and it's not going to work in the other, and then gotcha, right? That's not what we want to happen. So we're going to set it up where it's in one type, and we're going to set it up where it's in the other equation, right? And they're not going to get us, no way, no how. So let's go ahead and type in what these should be. So I'm going to do 2 times $5.75 plus 3 times 9 and see if that equals what it's supposed to equal. Okay, so it works in this case. What was this for? This was for May. All right, so in May it works. Let's see if it works in June. It does not work in June. Oh no, my pen's gonna die. If it doesn't work in June, that means it doesn't work in both. That means she is not correct. And this math here, all this substitution is perfect justification, totally fine. You don't need to explain any further. You just have to button it all up with a not correct and then show your math. Then for the last part, it says use your system. Is this the last part? We don't have to graph anything. Okay, sweet. It says use your system of equations to algebraically determine. Remember, algebraically determines mean you can't just write the answer because you typed it into LinSolve. You got to show all your math. A correct answer with no work shown is worth only 1 point. Both the actual cost of each matinee ticket and the actual cost of each regular ticket. So what I like to do is I like to type my answer in first, get what my answer is, and then I can know that my math is in the right track as I go, right? So these are two linear equations because it's two variables. Nothing is being raised to the second power, so I can just type it into LinSolve. So let's go ahead and use LinSolve to get our answer, then we know where we're headed, and then we can make our math focused and easy, okay? So let's type it in LinSolve. Menu 3, 2. Menu 3, 2. And then if they give me two different variables than what I usually work with, I'm gonna change it to m comma r because then I know exactly which one is which in my answer that they give me, right? So I'm changing it from x and y to m and r just because that's what the problem used. And then now I can just type in my equations the way I see them, right? 2m plus 3r equals 3850. And then 6m plus r equals 4750. And then I just type it in and I get m is 650. And R is 850. All right, cool. So that's where I'm headed. I'm going to need to make my math, or I'm going to know as I do my math if I'm on the right track or not, right? So I've got 2m. Oh no, my pen's dead. All right, I'm going to plug it in for like 15 seconds. And in the meantime, you can just think about all the fun things you're going to do when the Algebra Regents is over. I wish I could send you a picture of my dog right now. I think I should have some juice in this thing by now. Let's see. Yes. Okay. All right. So I have this format here where it's like all the M's are lined up, all the R's are lined up, and all the constants are lined up. When I have this format, I'm going to be using elimination. And in elimination, I'm going to want to multiply or scale up one of these equations by a positive or negative constant in order to make a variable disappear. And since R only has 1 in front of it, it's really easy to make him disappear. So I'm going to multiply this whole bottom thing by -3 to make them have an opposite sign and make it cancel. So now I'm going to distribute that -3 to each term in the parentheses, and I'm going to rewrite it here. So I've got 2m plus 3r equals 3850. Notice how the first equation remains untouched. The second equation, though, he's -18m minus 3r equals -3 times 4750. All right, now I can just add these two together. 2 minus 18 is going to give me -16m. These are going to cancel, and then now I'm going to have to do 38.5 minus this number here, and I get 181. Okay. Oh, it did minus a minus. I didn't want to do that. Just one plain old minus. There we go. -104. So now I'm going to divide both sides by -16. And I get 13/2, but I'm talking about money, so I want him to be a decimal. So I've got 650. Okay. And then now I need to find R, so I'm just going to plug him back into an original, one that you have not multiplied by anything. Okay, so I get 2 times 650 plus 3r equals 3850. 2 times 650, what's that going to give me? 13. $850. Yay, that's what the answer told me it was going to be. So I am all set and ready to go. Bye.